In this lesson, we'll learn a technique for setting up a fleshy eye system. It'd be nice to have the skin of the eyelids slide as the eyes rotate, and that's what we're about to set up in this lesson. So what we're going to do is create the illusion of that by adding some slight rotation to the eyelid joints. So we need to add on top of the expression that currently drives them that's tied to our user data. So let's go ahead and get started. We can start with the left upper lid. Let's go ahead and grab the tag, go ahead and expand the nodes out just so we can organize things a bit. So basically, what we need to do then is add the result of the range mapper plus the result of the rotation of our eye bone into our upper lid joint. And that's how we'll get that behavior. All right, so let's go ahead and get started here. We'll create a math node. We'll just right-click an empty space in our X group, and we'll choose Espresso Calculate. Let me go ahead and actually bring this up so you can see exactly what I'm choosing here. So that's Espresso Calculate, and we'll grab the math node. All right, so we're going to go ahead and leave the function set to add, because remember, we want to add the result of the range mapper and the rotation of the eye bone itself. Let's go ahead and select the eye bone and add that to our X group. For its output, we'll need to plug in its pitch axis. So it's going to be coordinates, rotation, pitch. Now we can plug this into the second input of our math node, and the first input will wire in our range mapper node. And now we can go ahead and take the output of the math node and wire that into the upper lid. Watch what happens now. I'll just minimize this. When we go to our eye control and start to rotate, you can see that the upper lid now follows. I'd say that the control is a bit much, but this is still very cool. Also notice this, if we were to go back to our main controller, we can still go in and freely animate a blink. Great stuff. You can do some very fun things with the add node. Essentially, we're able to control one parameter with multiple objects. So that's really exciting. I'm just going to go ahead and undo back to bring the eye back to its frozen state. If we were to scrub on the timeline, you can see that there's a slight shift in the upper lid, meaning that we'll need to adjust our priority. But we'll take care of that. Let's get back to our Espresso group so we can go ahead and only get part of the rotation of this eye bone or eyelid bone as we rotate our eye control. So to do that, we can go ahead and multiply a fraction of what we're getting using another math node. So let's go ahead and right-click and choose Espresso Calculate. We'll add another math node, and we'll set the function to multiply. Let's go ahead and rotate about 20%. So let's go ahead and set the second input to 0.2. And now we can take the pitch axis of our eye bone and wire that into the first input of this multiply node. We grab the output of that node and wire that into the second input of our add node. Now watch this when we minimize and as we start to rotate our eye controller. Now we're only getting a fraction of the amount. And that looks very nice. Much more realistic. Great stuff. So again, as we undo back, you can see that we're getting a bit of a snap in that bone object. No worries. All we need to do now, simply go to the Espresso tag and set the expression here to 1. So that's evaluated second. All right, great. So the rest of these are going to use the same priority, expression 1. So let's go ahead and set those up. And then we can go right in and set up the other nodes. So now we can go ahead and work on the lower lid. All right, let's go ahead and double click on our X group here. Go ahead and find our objects. We'll create our math node. And this will leave at add, have that set to add. Let's go ahead and clone this. We'll go ahead and set its function to multiply. We might try first just using 0.2 again just to see how that works, and if we need to, we can go ahead and drop that or increase it depending on what happens as the eye joint rotates. And speaking of which, let's go ahead and add that to our X group and add in the pitch axis. So again, that's coordinates, rotation, pitch. And now we can go ahead and have that wired into the first input. All right, beautiful. So now we can go ahead and take its output and wire that into the second input of our math node, grab the range mapper, wire that into the first input, and then go ahead and take the output of the add node and wire that into the rotation of the lower lid. Let's go ahead and take a look at what we get as we rotate our eye control. Notice we're getting some really nice behavior here. Now, if you find that the lower lid is rotating a bit too much, again, you could always drop that amount. So just testing things out here, we might use 10% instead of 20%. So I'll go ahead and set this to 0.1. Just see what that does. Just experimenting here. So as we start to rotate, notice we get a nice result from that as well. Great stuff. Very fun. All right, so that's the process for the right side. We can go ahead and set those up also. Should have the process down. So let's go ahead and grab the espresso tag. Let's organize things a bit. Add our first math node. Then we'll make sure to clone it. We'll go ahead and set the second math node's function to multiply and set that to 0.2 for our second input. We'll add in the right eye bone this time. Let's go ahead and select that. Find it. There it is. Add that to our X group. Find its pitch axis. And go ahead and wire that into the multiply node's first input. All right, great. Let's go ahead and wire its output into the second input of our add node, the range mapper into the first input, and then we could go ahead and take care of the output of the add node and test this out. We always want to test things out. Don't want to ever assume. Okay, that looks great. Let's go ahead and take care of the last joint to finish up. So that would be the right lower lid. There it is. Let's go ahead and load that in and finish up our fleshy eye rig. So again, this is just a technique. There are other ways you can go ahead and set this up, but I find that this way is not only simple, but very effective. Okay, great. So let's go ahead and, after cloning the math node, let's switch our function. Let's go ahead and set this to 0.1 for the second input of our multiply node. Let's find the eye bone for the right side. Grab the pitch axis and wire that into the first input of the multiply node. Grab that output and put that into the second input of the add node, and then take care of the range mapper node. And finally, we can go ahead and take the output into the pitch axis of our lower lid. Let's go ahead and close this out, grab our animation control, and test it. Beautiful stuff, very fun. Let's go ahead and see what happens when we grab our eye control object and start to move that around. Again, we get some very nice behavior now. Then we could go ahead and just double check our priority by grabbing, let's say, our upper jaw control, going to our rotate tool. Great, we can go back to the eyes and test those out. Very fun. All right, well, that finishes up our work here. I'll go ahead and undo back. And that finishes up our eye rig overall. So that means that we have the tongue left, and then we can get right to morph targets, and then setting those up to control them in an animator-friendly way. And then at that point, we can clean up our rig and call it good to go.